to do it, so we need to fulfill that commitment. Okay, now, here we go. Yesterday, what did we learn? We learned how to graph sine and cosine, and we incorporated period and amplitude changes. And we remember that if there's going to be a period or an amplitude change, those changes are caused by multipliers. When you put multipliers into your problem, you are changing the shape of the curve. You are stretching it or shrinking it. We remember that a number out here in front does what?
Makes it taller.
It multiplies the amplitude, so it affects the height. Since that's a 3, it absolutely will make it taller, right? What does a coefficient here do? A multiplier attached to the x. It changes the horizontal length. It divides the period. So, in this case, this sine curve would actually be half as long as a regular sine curve, right? Now, when you put additions and subtractions in the problem, that does not affect the shape. What does that affect? Where it is. You moved it around. You picked it up and put it down someplace else. We remember if we have attached to the x, that's a horizontal movement. And when it says x minus pi over 4, we actually know that moves to the right. Remember that? And then when you stick this thing on the end, clear on the end, plus 1, what does that do? Picks it up 1 unit. So we are going to today sketch a big bad sine function that's got everything that could possibly be going on in it. Everything is happening here. We've stretched, shrunk, moved it sideways, moved it up. All right, so here we go, one step at a time. What's the amplitude of this curve? 3. So I'm going to go ahead and set up my axis system. And here's 3. All right, what's my period? This goes back to yesterday. What's a period supposed to be on a sine curve? 2 pi. But when you put that coefficient in there, you've divided it, so your period is pi. Now that means that from start to finish of your sine curve, that hill and valley is going to be 1 pi. Now here's where things are a little bit different. Yesterday, I just did this, right? Because that's what sine curves do. The issue now, though, is this sine curve doesn't start at the origin. That's where sine curves are supposed to start, but what have I done to this picture? I moved it over. So now my sine curve is going to start at pi over 4. So I'm going to draw a sine curve, same shape as before, amplitude 3, but I'm starting it at pi over 4 because of this horizontal shift, or for some reason in trigonometry we refer to it as a phase shift. Now, you told me that the period was pi. Is this label pi? No. Why not? Because it didn't start at 0. If it started at 0, it would end at pi, but it didn't start at 0. So where's it going to end? Since it started at a 4th, and the period is a whole pi, where's it going to end? 1 1/4. Or I prefer to use 5/4. But that is 1 1/4. Remember, period is the distance of a hill and a valley. If you don't start until 1/4, then you're not going to end until 1 1/4. Does that make sense to you? Now you still have to label all of these things. Our life is full of fractions. You can't get away from them, unfortunately. What is halfway between? Just kind of use your common sense here. What's halfway between 1/4 and 5/4? 3/4. Remember, halfway is midpoint. Midpoint is average. 1 and 5 is 6 divided by 2 is 3. When you average, you add them and divide by 2. That's what midpoint is. So 1 and 5 is 6 divided by 2 is 3. So the middle is 3/4. What's halfway between 1 and 3? 2/4. And again, that's 1/2. I am not going to ever mark off if you don't reduce. A lot of times it's easier not to reduce. Because now you can see 1/4, 2/4, 3/4. What's this one going to be? 4/4, or plain pi. See how it goes 1, 2, 3, 4, 5? Right in the row, right in order, everything evenly spaced. That is a beautiful picture, but it's not the answer. Because what? I still have to move it up 1. So I'm going to use my trusty purple marker, and I'm going to take all of these key points and move them up 1 unit. The purple is the answer to the question. Would you all agree with that? Okay, they really don't get any harder than that. That's about all that we can do to it. So if you've got that one under control, then other than some maybe uglier arithmetic with bad fractions, it doesn't, I mean, that's it. That's all there is to it. Let's do this cosine one. What can you tell me about this cosine curve? It's upside down, so I'm going to give myself just a little hint over here to the side. It's going to have that shape, right? It's an upside down cosine. Okay. What else can you tell me about it? What's its amplitude? 2. So there's 2. Okay, what's its period? 2 pi divided by 1/2, which is 4 pi. That means that from here, from the bottom of the valley to the bottom of the valley, that space is going to be 4 pi. What's my phase shift? Left pi over 3. And we will either write, Madeline, left pi over 3, or we can indicate that with a negative. Either way, you have to say either negative pi over 3 or left pi over 3, which means that whatever this thing looks like, this is where it's starting. So it starts at the bottom of the valley and ends at the bottom of the valley. So there's what I've got. That's my negative cosine curve starting at negative pi over 3. Would you agree with that? Where's it going to end? Now be careful.
1/3.
From here to here is how far?
4 pi.
4 pi. So we're
4 pi
starting at negative pi over 3.
4 pi minus negative pi over 3.
So negative pi over 3 plus 4 pi, basically. I think that's what you said, just in the other order. So get a common denominator, that would be what? 12/3? So that would put me where? 11/3. Very good. Newman?
Why is it at -2?
You mean why did it start down here?
Yeah.
Okay, remember, cosine curves, positive cosine curves start at the top of the hill. So when you turn it upside down because of the negative, it's gonna start at the bottom of the valley.
Okay.
So that's just the shape of the curve. Would have got one period of it. All right, everybody figure out where the start?
For the period, is it, so it's 2 pi and then over the first coefficient, it's always 2 pi?
Maybe you and I can spend a little time on video tonight.
That works.
Okay, halfway, the top of the hill, what's that gonna be? All right, let's think midpoint, let's think midpoint. Midpoint is average. I want the midpoint or the average of -1 and 11. -1 plus 11 is, -1 plus 11 is 10, divided by 2 is 5. So this is 5 pi over 3. Again, everything is evenly spaced, so when you start splitting up this period, you're going to be finding midpoints. And midpoints are averages. You add and divide by 2. So this point right here, -1 plus 5 is divided by 2. So this is 2 pi over 3. Now my scale's off, not worried about it, everything's labeled. 5 and 11 is 16 divided by 2 is 8. Now I want you to just back up a minute and look. From -1 to 2, isn't that 3 steps? And then another 3, another 3, another 3. See how it's all evenly spaced? And we're all done except for one thing. We have to take it down 1. Our vertical shift is either down 1 or -1. You have to somehow indicate it's negative. So we're going to take all these key points and we're going to pull them down 1 unit. And the answer then is the purple. Wow.
So since we don't have like a marker and a purple, like we have to.
You will have either a colored pencil, or you will do this one in dashed,
Okay. So
or
you
you'll
want both
go
of
over
them?
this one real heavy with your pencil. Somehow you'll indicate which is the right answer.
Okay.
Now some kids don't even graph this one, they go straight to this. I can't keep track of all that. That's a lot to keep track of, phase shifting and labeling and dropping down and all that. So I always do it in 2 steps. But somehow, if you do it in 2 steps, you have to indicate which one's your answer. So a colored pencil works great
Okay.
if you have one. Or you could dash this one with your eraser. All right. That's all we have time for. Tonight you'll get to practice a few of those. I haven't assigned very many. I know that you got a lot of studying to do and stuff.